With this question, what we've got the cost of the electricity. So they tell us what it's costing him and how much it costs from the national grid and how much power he's using and the time he uses it for, and the cost. And all we have to do is use that cost equation. So cost is equal to power times time times cost per unit. In this case, he would use a maximum of 2 kilowatts for 3 hours, and it would cost him 15 pence for each kilowatt that he uses. So you multiply them together to give you 90p. Now the second question is a bit trickier because look, they give you a hint in the question. Okay, I don't think in fact they don't always do this, but here they've given you a hint. Power must be measured in watts, except in the cost equation, but we're not using the cost equation anymore, so power needs to be measured in watts again. Now if we look here, it says an electric kettle is plugged into a 230 volts main supply. It has a power of 2.5 kilowatts. Straight away that's a problem, because we need, in every other equation, power must be in watts, not kilowatts. So I've written this here. So 1 kilowatt is 1,000 watts. So if we want to get from kilowatts to watts, we need to multiply it by 1,000. So I've got my 2.5 kilowatts and I've multiplied it by 1,000, and that's going to give me 2,500 watts. Now we can use our equation because now we're happy that power is in watts. And so what we've got is current is equal to power divided by voltage. And so the current is equal to 2,500 watts divided by 230 volts. And that will give you whatever the answer is. Now, I don't have a calculator and I can't really do that in my head, so you guys can do that. Now it says, suggest why the 2 kilowatt wind power generator may not supply all the electrical energy needed in a house. So number one, there are loads of appliances in the house that need a lot more power. And number two, the wind is not constant, so you're not always going to get that same constant supply of electricity. Brilliant. So pause the video, check the next page. So this is that question that I was talking about the other day in the other video. I mean, it's like a length of a B, like what's that got to do with anything? But anyway, it's just getting you to see if you can, I don't know, think of scale. So I have seen some people take a B is 2 kilometers long, which is like, okay, whatever, whatever. But anyway, it is roughly 2 centimeters. Next question is the spectrum of light. Which one of these is from the spectrum of light? So the spectrum of light is when white light gets split by a prism into these colors. Not necessarily a prism, raindrops can do it, but this part is called the spectrum. This is the light that gets broken into the spectrum. Light, spectrum. Light, spectrum. Light, spectrum. You get the point. Colors of the spectrum. Richard of York gave battle in vain. Red, orange, yellow, green, blue, indigo, violet. Therefore, the answer is yellow. Black is not part of the spectrum, neither is brown, and white light is what it starts off with, and it gets split into the spectrum. Pause, check next question. Okay, so this is how I've done this one. I've basically drawn exactly a spot the difference type of thing, and what I've noticed is that the human eye on the left hand side at the lower frequency, because there's a frequency, at the lower end of the frequency, the human eye is more sensitive to visible light. Can you see the bumblebee is missing that one there? Let me just point out. So the bumblebee is missing this section here. So that's the human eye. The human eye is sensitive. The bumblebee is not sensitive. And here, the bumblebee has a sensitive area to ultraviolet light, but the human does not. And that's the difference. Spot the difference done. Next question. Let's pause. So this one, it's 230 hertz. Now, guys, it's audible sound. I mean, even if you think about that, you can hear a bee buzzing. So it's like you can even think about it and figure it out. But anyway, in any case, infrasound is below 20 hertz. Sound is 20 hertz to 20,000 hertz. Ultrasound is anything above 20,000 hertz. Kilohertz is just a short way of saying, guys, I'm repeating myself so much. The same questions are coming up every single time. Unbelievable. Now, so this again, I'm using Andrea's method. I've got I'm just highlighting whatever I've got. So I've got time in 4 minutes. That's straight away a problem because of course we want time in seconds. So I've written down my fact: 1 minute equals 60 seconds. So if I want to go from minutes to seconds, I need to multiply by 60. So I've got my 4 minutes and I've multiplied it by 60 to give me 240 seconds. So now I'm happy my time is in the correct units. Next I've got distance, which is 1,608 meters, and the question is saying what's the speed. I go to the front of my booklet and I see the equation that I need is speed is equal to distance divided by time. So it's 1608 meters divided by 240 seconds, and that'll give you whatever the speed is. I don't have a calculator. You guys can do that. A scientist wrote that basically ultraviolet is harmful to humans but good for bees. Why? Well, bees, if you look at the graph that we covered in the page earlier, but you don't need the graph because you're supposed to know this anyway, bees can use UV light to see flowers in different colors that we can't see, so it's more vivid, more brighter, whatever it might be, so that they are attracted to it. So that's their adaptation. Next, with humans, right, UV light can actually mutate genes to cause cancer, and also if it's reflecting off a white surface, in particular in snowy areas, it can damage your eyes. Now I just want to say using X-ray guns can be very, very dangerous. That is ultraviolet, X-rays and gamma rays. You see what I did there, using X-ray guns. While they can be dangerous because each one of those are high frequency electromagnetic spectrum, which can cause cancer by mutating your cells. Okay, so they're all quite dangerous. Pause. So here is a picture of amplitude. Amplitude is basically it's from resting position to either a peak or from resting position to a trough. Right, a wavelength is the position from one part of the wave to the exact same place on the next part of the wave. That's what a wavelength is. Just want to go through frequency. Frequency is the number of waves passing a point every second. And finally, because this is a transverse wave, I went for B. And I'll stop there and I'll upload the last section later.